Okay, welcome back. Today we're going to be talking about domain and range as it relates to a story problem. We're also going to be talking a little bit about decoding story problems to make this easier to graph and to find its domain and range. So let's look at the story problem that we got up here right now. So first thing we got is, let's read it. It says a submarine is at 100 feet below the surface. It then descends at 20 feet per second. So there's a couple key pieces of information here. First piece of information that we'd like to look at is 100 feet below the surface. And the other one is this 20 feet per second with this word descends. So that's the important information that we're given. Now, one of the things we're going to be looking for is we're going to be looking for a word per. So anytime you see this word per, you're in pretty good shape because this word per will tell you what the rate of change is. So look for the word per, and if we're looking through it, we see it right here. There's our word per. And what this word means is it's telling us where our rate of change is, and it always is accompanied by a couple things. There's going to be a word before it. There's going to be a word after it. And we generally have a number that's also associated with it. In this case, we have 20, the word feet, and the word seconds are what these three things are. Okay? So inside this box is generally going to be a number. Okay? This number right here is going to be your rate of change. So anytime you see that number, it's going to be your rate of change. In here is going to be your dependent quantity, and afterward is your independent quantity. And they're in alphabetic order, so it's easy to remember. It's dependent per independent. Okay? And that will tell you where your rate of change is. So when we start doing this over here, we're just looking for these key information. And once you have these top four, everything else we're going to do is pretty much done already. We just have to put it together. So we need the rate of change. Well, we just found out that anytime we see this word per, we look for the number in front of it. In this case, the number in front of it is a 20, so our rate of change is 20. However, we don't know whether or not it means a positive 20 or a negative 20. That's what we don't know. So we got to look back to the words in the problem and look and see, are we going up or are we going down based on the problem. So in this case, it says it descends at a rate of 20 feet per second. So this word descends means that our submarine is going down. Since we are going down, we're going to make it a negative 20. So our rate of change is negative 20 because it is going down at 20 feet per second. Okay, the next thing is they're going to ask you for is the y-intercept. The y-intercept is also known as your starting point. So it's where in the problem do we start. If we are going down at 20 feet per second, before we started going down, where were we at? Well, that's what this other information is telling us. It says we are at 100 feet. So this is where we started. We started at 100 feet, so our y-intercept is going to be 100. And just like before, we have to decide is it positive or negative. And it says if we start 100 feet below the surface, that's going to be negative 100 feet. Anything below the surface is going to be negative. Above the surface is positive. So this is negative 100 feet because we're below the surface. And this was negative 20 because we are descending. Okay? So next, dependent and independent, those came from around the word per. It says dependent is the one before per, so in this case it is feet. And then the independent right here is the one that's after the word per. So I looked after the word per, and what do we see? We see this word seconds. So independent is going to be seconds. And now we get to write our equation. Our equation is going to be in slope-intercept form, which is y equals mx plus b. B is our y-intercept. Well, we were just given the y-intercept. It's right here. So we already know our y-intercept. It's negative 100. M, as you know, is your slope. Well, another name for slope is rate of change. So here is your slope. So we called it rate of change. It's just slope. So we have our slope. We have our y-intercept. So writing the equation is easy. It's going to be y equals, instead of m, we're going to put in our slope, which is negative 20 x. And then we got plus negative 100, but we don't need to write the plus the negative. We're going to just write it as minus 100. And right there, there's our equation. So the only thing left is to graph this thing. So let's go ahead and graph it. I'm going to pick a different color just to be a little bit different down here. So we need a coordinate grid, which we got right now. And it says that we're going to be starting at negative 100, so I need to be below the surface at negative 100. So I'm going to count by 20s, so let's go with 20, 40, 60, 80, 1, 20, 40, 60, 82. Okay, so there's negative 100. And the first thing you do is at negative 100, we're going to put a dot. So there's our point. That's our y-intercept. Okay, the next thing is we're going to take the slope. And the slope says that we're going a slope of negative 20. Well, remember, we need a fraction because it's going to be rise over run. So we're going to put this over 1, because anytime we're missing the bottom of a fraction, we can put it over 1. So we got negative 20 over 1. That means starting right here, we go down 20. Remember, these are counting by 20s. So our next line here is negative 120. So we go down 20, and then we got to go over 1. So if we go down 20 over 1, we end up right there. And we could keep doing this again and again and again. And we're going to eventually have our line that goes right through those points. Okay, so the only thing left to do is to label our axes. Remember, left and right is x, up and down is y. But it's not good enough to just label them x and y. We need to say what we're measuring on these axes, and that's where this other information here comes in. Dependent is your y. Independent is going to be your x. So anytime I see independent, we're got to talk about x, and anytime we see dependent, we're going to talk about y. Well, it says x is seconds, so over here on the x-axis, we're going to label this one as seconds. And the y is labeled as feet, so we need to go up here to the y, and we're going to label this in terms of feet. And now we are done. So we have our graph, we have it labeled, and we are happy. So let's look at another example. In this example, it says Joe sells coffee at his coffee shop for $5. We need the rate of change, we need the y-intercept, the dependent, independent, and equation. Well, first thing I'm looking for is the word per. Unfortunately, the word per does not appear anywhere up here. So we got to figure out what we're going to do for the word per. So what you need to do is you need to rephrase this using the word per. So what I see is that we're selling coffee for $5. So I could re-say that as $5 per cup of coffee. Okay, so coffee is $5 per cup, or $5 per cup of coffee. So now I do have same information, but I have this word per back in here. So now remember, our key information is going to be the number and then the two words that are around the per. So we should be able to go over here now and write it. Our rate of change right here was 5. We have to decide if it's positive or negative. Well, if we're selling coffee, that means we're going to be making more and more money, so this number is going up, so it's going to be positive. The y-intercept doesn't say we started with any coffee sold, so we're going to assume that it's 0. Dependent is always the first one, so dependent is dollars. I'm going to use the dollar symbol. Independent is the one after here. It's going to be cups of coffee. And lastly, our equation. Well, remember, we're going to use y equals mx plus b. So we're going to use y equals 5x, and then our b is the y-intercept. It's plus 0, so we don't have to write plus 0. If you write plus 0 here, it's not wrong, but y equals 5x. So now we got to graph it. We have no y-intercept, so it's going to be at 0. And then it says you go up 5, 1, 2, 3, 4, 5, over 1, because remember this is 5 over 1. So go up 5 over 1, you end up right there, and we can draw a nice straight line. And we got to label our axes, so there's x, there's y. X is going to be measured in, independent is x, it's going to be measured in cups. And the y is the dependent, and the y is measured in money, so this is measured in dollars. And we now are completely done. So this is an example of how you take a story problem. You decode it to find the rate of change, the y-intercept, the dependent quantity, the independent quantity. Then you can take that information to write an equation, and you can also graph your equation. If you have any questions, please make sure you ask.